are given perfectly and nicely in that the recorded version of last semester that I already made the video, and it was in YouTube actually, so you can see from the canvas, you can go and look at it. So identify question number 3 says that identify whether they are odd electron molecule, electrodeficient molecule, or hypervalent molecules. Explain why they are considered exception to the octet rule. Here beryllium hydride, this is beryllium. If we look at the periodic table, we see that beryllium is 2 in group 2, so it has electron deficiency, or it can be said the electron deficient molecule. That means it will not need 8 electrons to cover up its I mean, it does not deserve that way, because it has a very small shell, outer shell, 1s2, 2s2 only. They don't have 2p, and that is why it is electron deficient molecule. That is so they just need 4 electrons to be covered so that they will be stable. So there are a few exceptions that we need to remember. And nitrogen oxide, no, not this one. Yeah. Okay. Yeah, so there is a nitrogen oxide, odd electron molecule, and that is why nitrogen is having a 1 electron on it. Oxygen is having 8 electrons, but nitrogen is having 7 electrons, right? So this is the closest to get to the octet rule. If there is 2 other examples that I have already outlined in that video, that nitrogen dioxide. Okay, one is nitrogen dioxide, another one is nitrate ion, NO3 negative. Another one, in that video you will find dinitrogen tetroxide, dinitrogen oxide, laughing gas, and then nitric acid, nitrogen dioxide, nitrogen trioxide or nitrate ion, and dinitrogen oxide, dinitrogen tetroxide, N2O4. You can start to produce the different Lewis structure for these different molecules. So this thing, all this thing you will find here, but this one you can try at home, and then if you are not sure, we can of course discuss about it later. So whenever there is a nitrogen compound, we need to be careful, because this needs an extra attention to finish this type of molecule, the structure with odd electron, different charges and different distribution of charges, and then this distribution of different type of bonding, 2 bond, 3 bond. It takes a bit of attention, so we need to do these type of practices. Another thing is aluminium. We know aluminium is electron deficient, right? So aluminium trichloride, and we can produce a one type of molecule structure, Lewis structure of aluminium trichloride. There is another one, is aluminium tetrachloride, right? So aluminium tetrachloride, Cl4, and aluminium all together it is negative. So in this case it will be the same thing, but only one only one chlorine will be attached here, and the whole thing will carry a charge. So aluminium is here, and then chlorine, and chlorine, all together it will be chlorine. Altogether, it will be chlorine. And in this case, which one will do? I mean, I want you to guess which of these elements in this molecule, aluminium or chlorine, will carry a charge for aluminium tetrachloride, I mean 4-chloride, right? So it is carrying one charge. Where will it carry the charge? Who will carry that charge? What do you think? Aluminium or chlorine? No? Or how do you know that who will carry a charge? If we calculate the formal charge, right? If we calculate the formal charge, then we will see that aluminium in this case getting a -1. So can it be good? Can it be good? What will be the difference if aluminium is carrying one negative charge and chlorine is carrying one negative charge? What is the difference between these two types? One is aluminium is carrying charge, right? One option. Another option is aluminium and then the 4-chlorine also attached to it, but chlorine is carrying one negative charge, not aluminium. So what is the difference between these two? Can anybody tell me? Any idea? What will be the difference? There is two possibility. So what is the difference? What is the difference? Anybody? Are you guys listening even? And sometimes I talk about the things for a few times also on the canvas, but you do not take note. That is the difficult thing. Okay, you should go and check with the canvas about the announcement and the guideline and everything, the information to the canvas, please. And if there is any I mean, if you are not sure or anything, you think that it is missing, please let me know. Okay, my question is here that aluminium and 4-chlorine elements are attached to aluminium, right? 4-chlorine elements are attached to aluminium. Okay. So one, there are two options. Aluminium can have negative charge, carrying a negative charge. Can, I'm not saying that it must. There is a possibility aluminium can carry. Another possibility that not aluminium, but one chlorine of them is carrying the negative charge. So my question is, what is the difference between that two? Which one will be more stable? Okay, I need an order. Thank you. So which one will be more stable, do you think? In that case, as per the formal charge rule, that the charge residing on the electronegative element, that is in this case chlorine, if the charge is on chlorine, then it will be much more stable than that of on the aluminium. But for this case, aluminium tetrachloride we are talking about here, this charge is born from this aluminium central atom. And that is why aluminium tetrachloride is not that stable. Okay. Okay, so Another example, another question is, since we are AlCl4, HClO4. HClO4. Okay, so in this case, interestingly, which one will be the central atom? HClO4 is Cl. Hydrogen is just can make one bonding. Chlorine is electronegative. Oxygen is even more electronegative, and chlorine also can make only one bond. So how does it make the bonding HClO4? This is another way. I mean, this will break the rule of Lewis structure that electronegativity element cannot be in the middle or something like that. And here as well, there is hydrogen, chlorine, and oxygen. There are 4 oxygen, so we understand that there will be 4 oxygen all around. Somehow it is attached to, and 1 chlorine and hydrogen. So oxygen are attached to each other, and then 1 hydrogen is attached somewhere and 1 chlorine is attached another way. So this is not the full one. This is one possibility only. There are other possibility for perchloric acid. There are other possibilities for perchloric acid to think or to consider which one will be much stable ion structure for perchloric acid structure. This is very strong acid. That means they are ready to release the hydrogen from here. That means hydrogen, I mean, it is not very stable. In that case, it is not very stable. That's why hydrogen is going out. So the structure, whatever you make, have to see, you have to know that the hydrogen should be available to be released from the molecule. Okay, hypervalent molecules which has more than 8 electrons. Xenon is another interesting element actually, because it can be odd electron, it could be even electron, it can be hypervalent. So not odd, but yeah, it's even, but sometimes hypervalent, sometimes super hypervalent. Okay, the xenon, and it can house up to 14 or 16 electron in the outer shell, and it is until that point it is taking electron. So it is super expendable for its outer shell or valence shell electrons, and it can form the bonding, or also it can form. And so same thing goes for phosphorus and sulfur. Phosphorus and sulfur, however, if they do not produce that many types, yes, phosphorus can produce PCl3, so 3 chloride, PCl6, so 6. So phosphorus can go beyond this octet to some extent and can until 5 phosphorus or 5 chlorine it can attach to until. It doesn't mean that it always will, but sometimes phosphorus trichloride also be prepared. Sulfur hexafluoride as well. So in this case, sulfur is having 12 electron. Aluminium is the electron deficient molecule, right? And this is the odd electron. So you can, I will post, I think I have posted it, not sure. If I don't, then I will post it, and then from there you can find the explanation why it is happening, how it is happening. Okay, so yeah, now I forgot what I want to say. Okay, is there any question today? Any other question? Hello. Is there any question? I'm done actually for this time today. So if you do not have any question, then I will meet you tomorrow. But Kishwan, I want to talk with you, and Audrey, also I want to talk with you about the lab actually. Don't be scared, nothing. Okay, so no other question, nothing. And I'll see you tomorrow afternoon for the... Sure, please. What is that question? Who is... Yeah, sure. I do have a question about who is yesterday, but wait, others to... don't have to leave, wait for others to leave. They can also learn if you have any questions, so that we can solve together. They will also be, they will also get the help from others as well, from the question you can ask. And